we've been talking about frequency and period in oscillatory motion. So this problem's kind of cool because we were talking about a mountain climber suspended from a nylon rope. And it gives you the force constant of the rope. You don't generally think about a rope being a spring, but in this case you have to. It's got some stretch in it, so it gives you the force constant is 1.4 times 10 to the negative fourth newtons per meter. So the problem asks, what is the frequency that the mountain climber bounces if his mass plus the mass of all of his gear is 90 kilograms? And it also asks how far it's going to stretch, how much give it has in the rope, which is actually kind of a real-world application using force constant and oscillatory motion. So we know our formula for frequency in a spring, in an oscillator, is 1 over 2 pi times the square root of k over m. So you plug in your variables to that right here, and you get that the frequency of his bounce, or his oscillation, is 1.99 hertz, right? Or about 2 per second. So that's kind of cool. Then you want to think about the energy that's stored in that spring. The second part of the question asks, how much would the rope stretch to catch him if he's in free fall and grabs it? Which is kind of a real-world application, because we want to know how quickly his body is going to stop when he's in free fall. So he's free falling 2 meters, which is the height that he falls, and we're going to use conservation of energy to solve this part of it. So the energy of the rope, which is how far it will stretch, is 1/2 kx squared, and the gravitational potential energy that he gains because he free falls for 2 meters is mgl or mgh. So we solve the conservation of energy for delta x, because that's the stretch in the spring or the nylon rope, and you solve it, you get 2 mgh over k to the 1/2, which is another way to write square root. So you plug in your numbers and you get, if you use 10 for gravity, you get that the rope will stretch about 50.7 centimeters. Make sure that you remember that to convert your units, I like to put things in meters, but this one makes a little bit more sense. It's about 1/2 meter. So you get that the frequency of his oscillation is around 2 hertz or 1.99 hertz, and the rope will actually stretch about 50.7 centimeters. So that's kind of a fun way to think about energy in springs, and I hope that you enjoy it, and good luck on your homework.